All right, we're in college algebra, graphing techniques, which is section 2.7. All right, what we're talking about on this is, let's talk about the quadratic. The quadratic function, okay, f of x equals x squared. As we mentioned before, if I do a table of values, if x is -2, -1, 0, 1, and 2, all right, -2 squared would be 4, -1 squared would be 1, 0 squared would be 0, 1 squared would be 1, 2 squared would be 4. I get this right here, and if I graph it, it looks like this. Which gives me this parabola. It looks like that. Okay. We know what happens if I have a function like this. Function of x is x squared plus 3. What happens to the graph there? And so what we're going to learn in this section today is how to graph something, or how to determine what's going to happen to a graph when we do some transformations, like when I add 3, or if I minus 2, or what if I add 3 and square it like this, versus what if I subtract 2 and do that. Okay, all these different functions, what's going on here? Okay, well, when I add and subtract numbers, whether I do it like this or if I do it like that, it's gonna shift the graph. The graph is still going to look the same, but all it's going to do is it's going to shift it to the left or the right or up and down. Now here's how you determine what it does. When I just add or subtract like these two here, this is just going to move it up or down or vertical. This is going to move it up 3. This is going to move it down 2. Okay? Which means on this one here, let's see, maybe I got more room on this side. This one here, that's going to move it up 3, which would have the same shape. So as I go over 1, this would go up 1. As I go over 1 this way, it'd go up 1. As I go over 2, it'd go up 1, 2, 3, 4. Let's go up 3. 1, 2, 3. It'd go up 4. I'm sorry. It'd go up 3 more from that one. And so here's my parabola. This point here I messed up. So basically, if you can still see this graph here, it's the same graph, but it's just shifted it up 3. What's that one going to do? It's going to shift it down 2. Let me just do it on the same one. There's my vertex right here, and as I go over 1, it goes up 1. As I go back 1, it goes up 1. As I go over 2, it'd go up 1, 2, 3, 4. As I go this way 2, it goes up 1, 2, 3, 4. It goes up 3 more from that point, which is what I accidentally did on that one a while ago, instead of going up 4. But you can see the graph makes this parabola, and I'm not drawing it very good, but it just shifts it, is all it does. Okay, so when you have plus or minus numbers like this, that's your vertical shift. Now, when you have numbers like this right here, when you're adding, subtracting, these numbers are getting squared along with the x. All right, this is going to be horizontal. Okay, and then what you got to remember though is this does the opposite thing. See, what happens is this: when I add 3, it has the opposite effect on the x values, which makes it move to the left 3. So this right here, plus 3, will move it to the left, whereas minus 2, that will move it to the right. It has the opposite effect on it. In other words, if x, all right, suppose I want this value here to be 5. So I want 5 squared. What would x have to be? Well, x would have to be 7, because 7 minus 2 would be 5, which means x has to be 2 more than 5, which means it moves it to the right. X would have to be 7, 2 more. So this minus 2 has the opposite effect on this x, which means it moves it to the right, which would be 2 more. As versus here, if I wanted this to be 5, I wanted 5 squared here. That means x would have to be 2. 2 plus 3 would be 5. 5 squared. So to get this same effect as 5, x would have to be 2, which is 3 less. So this plus 3 makes x have to be 3 less, which moves it to the left. Anyway, the main thing you got to remember is when you move horizontal, it does the opposite thing. So like this plus 3 moves to the left, minus 2 moves to the right. Okay? So your pluses and minuses are just going to shift your graph. Let me graph one like this. So there, here, this plus 3 is going to move it to the left, 1, 2, 3, which the vertex would move to here now. And then as I go over 1, it goes up 1. As I go over 2, it'd go up to 4. And as I go back this way 2, it goes up to 4. So you can see the same graph here is formed. I didn't do a very good job, but you can see how it's shifted over to the left. I could put values in for x to show you how it works. Like if I put negative 3 in, negative 3 plus 3 would be 0. 0 squared would be 0. So negative 3 is 0, see? If I put negative 4 in, negative 4 plus 3 would be negative 1, and negative 1 squared would be 1. So see, at negative 4 is 1. And every one of these values would work out. This one is going to move it this way to the right 2. And it'd be the same graph. But shift it to the right. Okay. Now, another thing we have is stretch. Now, the first thing was shift, vertical and horizontal shift. This is stretch. So if I have this same function of x, but I've got a 2 in front of it. All right, now, this is a multiplier. It's not an add or subtract. It's a multiplier. Okay? Which means it's going to speed it up as far as how high up it goes. So now normal, let me draw the normal one on here, okay? We'll do it again. So this will be here. This is the normal graph. Okay? Which looks like this. All right, if I put a 2 multiplier in there, let me draw my table of values for this. Negative 2, negative 1, 0, 1, and 2. All right, now if I put negative 2 in there, negative 2 squared would be 4, but I got 2 times 4, which would be 8. If I put negative 1 in, negative 1 squared would be 1. 2 times 1 would be 2. If I put 0 in, 0 squared is 0. 2 times 0 would be 0. Putting 1 in would give me 1 squared would be 1. 2 times 1 would be 2. And then putting 2 in, 2 squared is 4. Times 2 would be 8. So I'd have these values. But look what it does to the graph when I put them in. Negative 2 would be 8, which is up here. Negative 1 is 2. 0 is 0, so that's still the same. Positive 1 would be 2. And then positive 2 would be 8. Oh, here, let me try the different with the black here. So it does this right here. Now this is curved. It looks kind of like straight. Oh, that was awful. There's what it does. It stretches it. See how much taller it is now? It's taller and it's more skinny. I've got this rubber band here. Okay, see this rubber band? But look what happens when I stretch it. See, it gets a lot longer, but look, it gets skinnier. Look how much skinnier it gets. Look, see how thick it is looking? But when I stretch it, see how skinny it gets? And I'm stretching it pretty far, man. This is a big rubber band. But that's what happens here. This is stretching it. It's making it stretch out like the rubber band, but it makes it more narrow. See the narrowness of it versus what it was originally? That's what happens on a stretch. So our basic transformations that we have on graphs are shifting and stretching. Okay? So now let's look at some applications of this and see what we can come up with. All right, so Right here, number 1. Fill in the blank to correctly complete the following sentence. To graph this function, f of x equals x squared minus 16. All right, see what we got here? We got a shift because it's minusing. It's adding and subtracting is a shift. What does it do? It's going to go down 16. Okay, look at this one. What does this one do right here? Look, we got a plus 10. That's going to go up 10. Okay, remember now, when you have a plus or minus number, it's vertical. Now, if this plus 10 was in the parentheses and squared, now that would be horizontal. These are vertical because they're not inside getting squared with the x. When it's inside getting squared with the x, that makes it horizontal, which is what we have here. Okay? So you've got a horizontal here. See how it's plus 13, which means it does the opposite, so it's going to go this way, 13 to the left. Okay, so this is going to go to the left. This will be to the left. Okay. Number 4. What do we have going on right here? All right, look, it's in the parentheses, which means it's horizontal, and it does the opposite. So this minus 7 is going to move it to the right. Okay. What do we have going on here? All right, now look here. We've got 2 different ones going on in this one. What does this do right here? Well, this is horizontal. When it's inside there, it's going to move left or right. And this is a plus 6, which means it's going to move it to the left. It does the opposite, so it's going to go to the minus 6 side. And then this is going to go down 7. All right, so this is going to go to the left, 6, and then down 7. Okay? That's number 5. Okay, now let's go to number 6 here. All right. Fill in the blanks to correctly complete the following sentence. To obtain the graph of this, all right, look here. This minus 5, that's horizontal, and it does the opposite, so it's going to go to the positive 5 side. This is vertical, which is going up 8. So we're going to go to the right 5, and we're going to go up 8. Okay? All right, so basically, if it's in the parentheses, that's horizontal, and it does the opposite. And if it's not in parentheses, that's vertical, and it does whatever it says. So it's like this is up 8. If this was minus, it would go down 8. All right, so now here we've got a few of them. Okay, match each equation in column 1 with its description from column 2. All right, what do we have going on right here in this first one? All right, well, it looks like since it's in the parentheses, that's horizontal, and it does the opposite. So that's going to go to the right 2. Right here, this is to the right 2. That's E. Okay, what about this one here? All right, this is not in parentheses, which is vertical. So this is going to go up or down, and it's minus 2, which means it's going to go down 2. All right, that's D. All right, over here, we got a multiplier. See the difference in these twos? They're all doing different things, but see this multiplier. This is a multiplier which is going to stretch it 2. All right, so this is going to be a vertical stretch by factor 2. This is C. Okay, look what my 2's doing here. It's in the parentheses, which is horizontal. It's going to move left or right. Okay, but see, it does the opposite. So this plus 2 means it's going to go to the left 2. That's B. And of course, this has to be A, right? We didn't do A, but let's look. See, it's not in parentheses, which means it's vertical. And it's positive, so it's going to go up 2, and that's A. All right. Here's more. Okay, let's see here. Okay, I got my pictures down. All right, I got some scissors here. I'm gonna cut this. Okay. All right, so we've got these graphs to look at. to answer these questions. So let me see if I can get them all on there at one time. All right, that'll work, won't it? All right, so which one's the correct graph of this one? Now this is x squared, which these are all parabolas. So they're all x squared, it's parabolas. All right, now this has a parabola, and it has a plus 5. Now what's this plus 5 doing? Well, it's not getting squared with the x, so this is vertical. It's going to go up 5. So I'm looking for the graph that just moves up 5. Which one of them moves up 5? It looks like B here. See how this is moved up 5? So this would be B. Okay. What about number 2? Or B, whatever, part B. What's going on here? All right, this is the same kind of thing where the 5 is not getting squared with the x. So this is just going to move it vertical. Okay, so it's down 5. So now look for the one that moves down 5. Okay, that looks like A right here. So that's A. Okay, all right, moving up to the next one. What do we have going on here? Now, notice the difference between these. See how the 5 is in the parentheses? The 5 is not there. This is horizontal, and horizontal does the opposite. So since that says plus 5, that's going to go to the left 5. So I'm looking for the graph that shifts to the left 5. And, oh, here it is, right here, G. Okay. And then, all right, here you go. Same thing here. It's in the parentheses, which is horizontal, and it does the opposite. So this minus 5, that's going to move it to the right 5. And right here, yeah, C. Okay. All right, let's go to E here. E. All right, we got a multiplier, which is stretching it. See the 5? See the difference between the 5 up here and the 5 there? This 5 is a multiplier, which stretches it, which is going to make it go real tall and get real skinny, like the rubber band did. So which one gets real tall and skinny? Right there, F. Okay. All right, okay, now we didn't talk about this. When you have a negative, a reflection. When you have a negative in there, it's going to reflect it, which makes it go down like this. Okay, so I didn't talk about that a minute ago. I just kind of forgot about it, I guess. I don't know. But look, it's got a 4, which means it's stretching it. So it's going to make it real skinny and tall, but it's going to go down because of that negative. So which one looks like it gets real skinny and tall, but goes down instead of going up? I think it's right here. So that would be D. See how it's reflected down? That's what the negative does. So let's go on, and we still got 3 more of these. Okay. G here. On G. Okay, now look here. We've got a couple of transformations. We got -5 in here getting squared. So this is horizontal, which makes it go this way 5. And then the +4, this is vertical, which is going to go up 4. So I need to take my graph, and it's got to go over 5, and it's got to go up 4. So do you see one that does that one? Yeah, right here, H. See, it goes over 5 and up 4. All right, what about the next one here? All right, we've got 2 transformations. Now this is horizontal, which is going to go this way 5 and up 4. So it goes to the left 5 and up 4. Okay, that looks like E. And then here's my last one right here. Okay, we've got 2 transformations again. This is going to go horizontal, and it's going to go this way 5, and this is going to go down 4. Okay, where's that one at? Here, I. Okay, so there's all my answers for that. Here's another one. Let me do the same thing here. I'm going to have to cut this paper. do that. All right, now these are absolute values. And you notice the pictures. Yeah, all these are absolute value graphs. Let's get them on there. You see them a little better. Okay. All right. So now on this one here, all right, the absolute value, and I notice, see the 6? It's in the absolute value bars, which is going to move it horizontal. And it's going to do the opposite thing, so it's going to move it this way to the right 6. So which one moves to the right 6? Here. See that? It's moved to the right 6. So that's F. Okay. All right, part B. All right, look here. See the difference? Look, this is a good comparison, something to look at here. See how this minus 6 is in the absolute value bars? This minus 6 is not in the absolute value bars. So this is vertical. This was horizontal, but this one's vertical, which is going to move it down. So this is going to move down 6. So look for the graph that's moved down 6. It looks like C right here. Okay. All right, part C. All right, now look here. We're going to have, let me go ahead and go up a bit more. Oh, no, I thought this next one was going to be like in the absolute value bars, but it's not. All right, see my absolute value of X. Then I have plus 6. This is vertical, which is going to move it up 6. So look for the graph that moves up 6, and it looks like right there, H. Sometimes just spot them right off, and sometimes I have to search for it. All right, now D here, see the difference from the 6 here? It's multiplied, which is going to stretch it. So it's going to stretch it. It's going to make it get real tall and skinny. I think we're looking at D right here on this one. See how it's getting real tall but skinny. Okay, all right, here's a reflection. See the minus? That's going to reflect it, which makes it open downward. So which graph looks like it's opening downward? So here it is, G. Okay, on this one, all right, okay, now look here. Look at the difference here between these negatives. Now, we're not going to have much like this, so it's not really something to fret over. But when your negative is in here, okay, here's the regular graph. When the negative's out here, it reflects it downward, which makes it go down here like this. Okay, when your negative is in there, that's horizontal. Anytime it's in there with the X, it does horizontal. So that's going to reflect it this way, which this part will come over here and that part will come over here. So it's actually the same looking on this. All right, so that would be A. Exact same thing. All right, now look here. We've got a negative, which is going to reflect it. Now see, the negative is outside like that one, so it's going to reflect it down. But I got a stretch also. So it's going to go down, but it's going to make it skinny and tall going down. Right here, E. See how it does it? It's getting skinny, and it's going down. So that's E. All right, a couple more. All right, H here. All right, see here, we got two transformations going on. This is horizontal, which is going to make it go this way because it does the opposite. This is going to go up. So we're going to go to the right and we're going to go up. So it's going to look for the graph that goes to the right 6 and then it goes up 6. Right here. I. See, it goes to the right 6 and it goes up 6. I. And then one last one. Okay. All right, there's two transformations on this one. This is horizontal. Now see, it's plus 6 in there, which does the opposite. So it's going to go to the left 6, and then this is going to go down. So this is going to go to the left and down. Which one does that one? Right here, B. See, it's going to go to the left 6 and down 6. So this is B. Okay. All right. Now, we're going to have to go to the computer. So when you get to number 10, you're going to have to graph these yourself. Okay. All right, so on this one, all right, we're going to click the graph and see it's absolute value bar. So we got to tell it we're doing absolute value. So this absolute value right there. Okay. Now, there's no shift, so the vertex of this is going to be right there at 0, 0, so I clicked on it. Okay, you can see how it's going to make a V here. Okay, now all I do on this, see it's got a stretch of 10, which means when I go over 1, usually I go up 1. Okay, and you can see here when I go over 1, usually it goes up 1. This is what the normal graph looks like. But this 10 is stretching it, which means when I go over 1, I go up 10. So I need to take this all the way up to 10. Now you can, there it is, see it? See my 110 right here? That tells me where I'm at right now. So I'm going to click that, and there you go. There's my graph. Okay, nice work. Okay, and I think that's all we had to do there. Let's go to 11. There's a few of these. We got to graph them. All right, graph this one. All right, look, it's x squared. So I click the graph. Knowing this function's x squared, it's going to make a parabola like that. Okay. All right, what I have going on now, I've got this -7, which is going to shift it down 7. So my vertex is going to go down here, down 7 right there. Oh, okay. I forgot. This one has these little boxes. And so we're just going to fill the stuff in and it will graph it for us. So we don't have any stretch, no horizontal stretch or vertical stretch. We don't have any horizontal shift, but what we do have is vertical shift. It's vertical shift down 7, so I'm going to put -7. Okay, and then when I do that, look, it's moved it down 7. And that's all we have. All right, well done. Okay, number 12. Okay, x squared plus 8. All right, we're going to click the graph. This is another parabola. And I can just click the graph anywhere because these boxes are going to come on. Let's see, there's what the normal function looks like. All right, what does this plus 8 do? That's going to shift it up 8. So there's no vertical stretch. There's no horizontal stretch. There's no horizontal shift. What we have is vertical shift, and this is up 8, which is +8. So I'm just going to put a +8 right there. And there you go. See that shifted it up 8? Okay, good deal. 13. All right, okay. Now here we've got one that's got horizontal shift. So we're doing a parabola again. So we click the graph. This is a parabola, quadratic. Just click the graph and these boxes come on. Now look here, see this -1? What does this do? It's going to shift it to the right one, which it doesn't have any of these. It doesn't have any stretch, doesn't have vertical shift. It's got horizontal shift. And remember, it's the opposite of that. So it's going to shift it to the right one. So this would be a +1. Okay, see, this is a -1 in the problem, but it has the opposite effect, which moves it to the right one, which is +1. Okay, and then you could check, see how it moved it over. Oh, I didn't click it. I just went and clicked my answer, but okay, was that 12 we did? I done forgot. That was 13. All right, here's 14. Okay, all right, we got, this is horizontal again. See, it's clearly to see that it's in the parentheses, so that tells you it's horizontal. If it's not in the parentheses, that's vertical. Okay, so now I click the graph. It's a parabola. And then if I click on the graph anywhere, these boxes come on. There's no vertical stretch, no horizontal stretch, no vertical shift. We have horizontal shift. And see, this is +10, which moves it to the -10 side. So this should be -10 in here. Okay, and then if you just click the graph, it should move it over to the left like it's supposed to. You can just click the graph to see what if it does the right thing. And it does, so we're good. Okay, 15. Okay, all right, we got absolute value this time, so I'm going to click the graph, and this is the absolute value. Now on this one here, now I think this one here is not going to do the boxes. But now if you look at it now, my vertex, see this +3? It's going to move it up 3. So I'm going to go up to 3 here, click there. And now see it's going to do my graph a little differently. Okay. And there's no stretch. So when I go over 1, it's going to go up 1 like normal. Okay. Now, if it had a stretch, like a 4 in there, when I go over 1, I'd have to go up 4. All right. 16. Okay. All right. Now, this is a cube function. So I click the graph. We're going to do this cube function. Now, I think this is going to have boxes, I believe. Yep. The absolute values don't have boxes, but the other ones do. All right, so if I look at this, all right, we don't have any stretch, so there's no vertical stretch, no horizontal stretch. Those are multipliers, but now we do have this minus out front, which is a reflection. Okay, so this is a y reflection because it's reflecting over the x-axis. I think that's right now. No, hold on. It's reflecting over the x-axis, which would be an x reflection. It reflects over x-axis. Okay, so you can see how it reflected. Okay. Now, this +6, that's in the parentheses, which is horizontal. So we've got horizontal shift here. This says +6, and it does the opposite. So this would be -6. Okay, and see that's moved over 6. We can check it. All right, well done. Okay, 17. Okay, all right, here we go. We got a bunch of stuff here. We got a stretch there. We've got horizontal shift and vertical shift. So we click the graph. This is a parabola. We just click the graph because the boxes come on. All right, we've got vertical stretch of 2. So right here, vertical stretch, make that a 2. Okay. Watch now, when I click this box, see it applied it. Okay. We've got vertical shift right there. See the -5? That's going to move it to the right 5. So right here, I just put a +5. And if I click the graph, see how... Oh, I'm sorry. I put in the wrong box. That 5 should have been over here. See now, I clicked on it and it moved it up instead of over. I just put that in the wrong box. My vertical is -2, which is going to go down 2, so I put -2 here. And then there you go. So double checking, I got my stretch. You can see how it's skinny now. It's stretched it. This horizontal shift, it moved to the right 5, and then this my vertical shift, which is going to move it down 2. So we're looking good there. Well done. And then 18. I think 18, yeah, we'll do it on the paper. Let's do 17. Now let's do another one like that one, okay? Just for your benefit. Okay. So we're going to graph this one, see how it's x squared, see how it's squared. This is quadratic, so we're going to click the quadratic and then click the boxes. Come on. All right, right there's a stretch of 4. So right here, vertical stretch, this should be 4. All right, then right here, here's my horizontal shift. And see it's -3, which is going to move it to the +3. So it's going to make it go this way 3. So in horizontal shift, this should be +3 here. And then this is my vertical shift, which is going down 4. So vertical shift there, -4. Okay, and you can click these other boxes. You can see how it moves it around. But you see it's stretched. See it's real skinny on this one because it's a 4. And it's moved over to the right 3, and it's gone down 4. And there you go. Let's do one more like that. Okay. All right, so I click the graph. This is quadratic. All right, I got this, click the graph, and the boxes come on. All right, I've got this vertical stretch of 3. So my vertical stretch is 3 here. All right, watch the graph real closely here. When I click this box, it'll apply the 3 shift. Watch the difference here when I click on this. Ready? Did you see it? All right, now my -5, that's horizontal shift, which is going to move it to the right 5. So horizontal shift, this should be +5. This is always going to be opposite. All right, I'm going to click this box and watch it apply it when I do it. Bam! See, it moved it over 5. And now this -3 right here is going to move it down 3. That's my vertical. So I'm just going to do -3 here. And watch it go down 3 when I click this box here. Bam! And that should be it. Okay? All right. Now the rest of these, let me go back to the paper here. All right. Graph the following function. This is a square root function, which remember, if you remember the parent function, it does this, over 1 up 1, over 2, 4 up 2. It looks like this. This is what the normal or the parent function looks like. That's what they call it, the parent function. What's going on here? Well, all I have is this +3. And see, the 3 is in the radical. See, it's not like this. See, this right here would be vertical. But this is horizontal. Okay, writing kind of sloppy because I'm in a hurry. Now, this +3 means it's going to move it to the left 3. So I'm looking for this graph that's moved to the left 3, which looks like right there, C. Okay, see, this looks like it's moved up 3. This looks like it's maybe moved down 3. This looks like it's moved to the right 3. Okay, but this one moves to the left. Okay, and then the last problem here. Okay, we've got the stretch here with this 4. We've got our radical here of x, and then we have this +2, which that looks like a vertical shift. Okay. All right. So can you see this up here? I can't get it all. I'll just draw it again. So here's the normal function. There's what the normal square root function looks like. Okay, that's what the normal one looks like. All right, this has a stretch of 4, which means when I go over 1, usually I go up 1. But that's going to stretch it. It's going to make it go up 1, 2, 3. It's going to make it go way up to here, which is going to make it do something kind of like this. Okay, but then I got this +2, which is going to shift it up 2. So instead of starting here, it's going to shift up 2 and start there. Okay, it looks like C. That is C. See, it shifted it up 2. So 1, 2. It starts right there. And you can see how it stretched the 4 here, and it makes it do that. This is stretched, but see, this moved down 2 instead of moving up 2. So see, that's not right. And this kind of stretched it horizontally. So it did, but that's not what we got going on. Anyway, these are graphing techniques and transformations. And hopefully you guys don't need any help with that. But if you do, contact me and I'll help you all I can. All right? So hope you have a good rest of the day.